Hi everyone. So today we're talking about the quadratic formula. I'm going to try hard not to have too many crazy coughing fits during this video, but no promises. We've talked about the quadratic formula a little bit already right before Christmas break, but I promised you that we would be learning it as a formal lesson later on. So today's the day. And today we will actually only be covering the first half of the lesson, just these first three examples, basically the front page of your notes here. So let's talk about what the quadratic formula is used for, and then we'll talk about how to actually do it. The quadratic formula is used to solve quadratic equations, okay? And I put a note in here just to remind you that when I say solve, what that actually means is to find the value of x, find what x equals. Now, we've never needed a fancy formula before to solve something. So for example, if I give you 3x plus 1 equals 7, we haven't needed a formula to solve that. We've just been smart enough to say, well, I would subtract 1 and then I divide by 3 and then I would know what x is, okay? Even if I throw a square in there, so now technically I'm looking at a quadratic, we could subtract 1, divide by 3, and then just take a square root and we'd be okay. Here's where the problem comes in. The problem comes in when I have that x squared in there, but also a regular x. Let's just say this, okay? Now I can't solve it like I normally would because I could subtract 1, that'd be fine, but then I have this 3x squared and this 2x. I can't combine them because they're not like terms. I can't move 1 to the other side because it's not going to get me anywhere. I can't get either x by itself is the problem now. So that's where this quadratic formula is useful, okay? It's for a situation like this, a quadratic that has both an x squared and an x in it, okay? And you're trying to find the value of x. Okay, so now that I've convinced you that it's necessary, here's the formula. It's negative b, that's a plus or minus sign, we'll talk about that in a minute, the square root of b squared minus 4ac all over 2a. And I know that sounds complicated. You do need to memorize that formula. Okay, now I'm hoping that we're going to use it enough and you're going to write it enough that you'll start to kind of internalize it. But it is going to be important as you're working through these problems that you be writing it out every time because that's going to help you remember it. And just one more reminder for you, all these a's, b's, and c's come from standard form of a quadratic, which looks like this. And then in these problems, we're always going to want this equal to 0. Okay? So once you have it looking like this, you've got your A, your B, and your C. We plug it in, and then we go from there. So let's take a look at that first example. I'm trying to solve, meaning I'm trying to figure out what x equals. I actually want to leave the formula on there. I can't start using this formula until I have the equation in this form. So I'm going to slide this 7x over to the other side by subtracting it. Now when I subtract it over here on the left, I'm not actually subtracting it from anything, okay? It can't combine with the 2x squared and it can't combine with the 4. I'm just kind of moving it so that this side over here is now a 0. And then this side I would rewrite as 2x squared minus 7x minus 4 equals 0. So that's always your first step, is to get yourself into this form, okay? And then you've got A, B, and C here. So I'm going to go ahead and plug into the formula. The formula says I want to do negative b. Now if b is already negative, that's going to make it positive, so that'd be positive 7 plus or minus the square root of b squared. Now notice how I'm putting this in parentheses. That is super crucial anytime that b value is negative. And really, if I were you, I would just get in the habit of always putting it in parentheses. Minus 4 times my a value, which is 2, times my c value, which is negative 4, all over 2 times my a value, which is 2. Okay, the first thing I would start with here is this chunk underneath the square root, okay? Now notice I'm not actually going to do the square root with it. I'm just going to crunch those numbers. And there's a reason for that, and the reason won't be so obvious until a couple of lessons down the road, but I promise you it'll be easier for you later if you get used to not including the square root here. So I'm going to go negative 7 squared minus 4 times 2 times negative 4. And I end up with 81. Okay? And at the same time, I'm going to go ahead and just do this 2 times 2 down here as well. Okay? So I can rewrite this now as 7 plus or minus the square root of 81 over 4. Now, my next step is going to be to take the square root of that 81, but I'm also going to deal with that plus or minus here. What that really is that's combining two problems in one, okay? Remember how when you take a square root, technically, like the answer here is 9, but it should be positive 9 or negative 9? That's where that comes in. And so we're going to crunch the numbers two different ways. We've got a split here. And so one of them is going to be with a plus, 7 plus 9 over 4, and one of them with a minus 9, 7 minus 9 over 4. When you do this part, hopefully your brain will just do the work for you, but if you need to use your calculator, do make sure that you put parentheses around that top piece. This is really just 16 over 4, which is 4. And then this would be negative 2 over 4, which is negative 1/2 or negative 0.5. Okay? And so that means in this original equation, if I had plugged in a 4 for x or a negative 0.5, I would have come out with a true equation. Okay? These are my two final answers here. And in most cases, you are going to end up with two answers. We're going to talk later this week about some other situations. Okay, so let's move on to example 2. And I just caught a mistake that I made in example 2, which is why I kind of got distracted midway through that problem. But this isn't set equal to anything, so I can't solve it because it's not an equation. This should be equal to 0. Okay, and that should have been written as part of the original problem. But okay, so it says solve and round your solutions to the nearest tenth, which is maybe an indicator that our answers aren't going to come out so clean and pretty this time around. Okay, but let's try it. So negative b, so that would be negative 3, plus or minus the square root of b squared, notice I'm putting that in parentheses, minus 4 times a times c all over 2 times a. Okay? I'm going to go ahead and do what's under the square root there. So I'm doing 3 squared minus 4 times 7 times negative 2, and I get 65, so close to being a perfect square. Okay, now, because this says round to the nearest tenth, I know that decimals are going to be okay in my answer, meaning I'm going to go ahead in my calculator and do the square root of 65 and just use that ugly decimal there, okay? And it says round to the nearest tenth, so I'll go ahead and make that an 8.1, all right? Later this week, actually the second part of this lesson, we're going to talk about a more precise way to deal with these things that are not perfect squares. But for today, because the directions say round to the nearest tenth, I'm okay with the 8.1. So I'm going to make this negative 3 plus 8.1 over 14. I'm going to make this negative 3 minus 8.1 over 14. What's this equal? What's this equal? If you need to use your calculator here, that's okay. Again, make sure you put the top part in parentheses. So negative 3 plus 8.1 divided by 14. Okay, and we get, then it says round to the nearest tenth, so I'm just going to go 0.4 here. Now to do this one, just a calculator trick here for you. Really, this next one's going to look exactly the same as this, except we want to change that to a minus sign, right? So if you hit second and enter, it'll bring it up what you typed in before, and then you can just use your arrows and go over there and change that to a minus sign. Okay, so maybe try that sometime. So here I get negative 0.8. Okay, so sometimes our answers aren't going to come out clean and pretty. Okay, and that's okay. Just follow your directions in terms of rounding, or if it asks for an exact answer, we're going to talk about that in the second half of this lesson. Okay, so one more example to cover today. And notice this question is totally different than the first two. The first two said solve. This one says find the x-intercepts. Okay, well look at this. Well, anytime we're finding the x-intercepts for anything, we know that y is going to equal 0, right? That's what we learned about x-intercepts, is it's where y equals 0. So I can take this y and replace it with a 0, and then I need to figure out what x equals, or in other words, I need to solve it. So really, this is asking you the exact same thing. So the quadratic formula will also let you find the x-intercepts of one of these quadratics, okay? So let's go ahead with the quadratic formula. I'm going to go negative b, so that would actually be a positive 2, plus or minus square root of b squared in parentheses minus 4 times a times c all over 2 times a. I'm going to do what's under the square root there. I believe that's going to come out to be a 16. 4 plus 12 is 16. Yep, so I get 2 plus or minus square root of 16 over negative 6. Okay? Split. Square root of 16 is 4, so I can say 2 plus 4 divided by negative 6. And I can do 2 minus 4 divided by negative 6. Let's see, that's going to be 6 over negative 6, which is negative 1. And this is going to be negative 2 over negative 6, which would reduce to positive 1/3 or 0.3 repeating. I like my fractions a little better. Okay, and I want to just take a second and point out the implication here. We just found the x-intercepts of this thing. Okay, and we know from what we already did in chapter 6 that this thing, when I graph it, would be a parabola, right? So if I was to graph that original equation, I'm going to do that right now. Oh, ignore that bell. Negative 3x squared minus 2x plus 1. I'm just going to zoom 6 here. What we should see, and I might zoom in so you can see that a little better, is we're crossing the x-axis at negative 1 and at positive 1/3. Okay, so not only is the quadratic formula good for solving these equations, but it's also good for finding intercepts. Okay, if you're asked to find the x-intercepts of one of these parabolas, which actually comes up quite often in these types of questions, I've been shielding you from it so far, but it's something you need to know. You can use the quadratic formula to find where your zeros are here. Okay, so that's about it for today. Like I said, we're going to do the second half of this lesson tomorrow in class. Today is really just all about practicing using the quadratic formula, and you can assume that you're safe to use decimal approximations on any of the assignment I give you for tonight. Tonight's assignment, by the way, is out of the textbook. It's section 6-7. Should be posted in Blackboard for you or in the board in class. Okay? So good luck. We'll go over this tomorrow.